So two things that we can include in our experiments, right? We were starting to design experiments on Friday. Two things we can include are what's called blinding and double blinding. Blinding, the units do not know which treatment they are getting. So I'm in an experiment, right? I'm testing out some new pill that makes you smarter, something that they claim makes you smarter. So they give me the pill and I take it and I go on with my day. The next day I come in, I take it, I go on with my day. They don't tell me. If they don't tell me which pill I'm getting, it's called blinding, okay? They don't tell me which pill I'm getting. I think, I'm getting the real pill, but I could be getting a placebo. That's called blinding, okay? Double blind is if I still don't know, and the nurse or whoever is giving me the pill doesn't know either. The person administering it. Neither the subjects nor the evaluator know which treatment a subject is received, nor anybody who administers the treatments or cares for the subject. So people who meet with the subjects, anybody who meets with them, doctors, nurses, whoever, if it's a medical experiment, they don't know which one you're getting. They have no idea which group you're in, which one you're getting. Basically, anybody who interacts directly with the people in the experiment. Well, who does know that? Isn't that a problem? Somebody has to know which one I'm getting. How did they get around that? Usually you'll have a doctor who runs. Usually there's only like one or two people in the whole organization who know which one you're getting. And those people never talk to you because they don't want to give anything away, whether it's on purpose or subliminally or whatever, they don't, whether it's conscious or unconsciously given, they don't want to give anything away. So all medical experiments are double blind for that reason. For that reason, they are double blinded, right? Because if someone really wants to know which pill they're getting, right, they can possibly get an answer from someone who interacts with them, right? But if those people don't know, they can't do anything about it. They're like, I don't know. I honestly don't know. So it's always someone who doesn't have interaction with them. Okay. So blinding and double blinding, that's one type of things. They're called components. So when we're talking about control versus control group versus treatment group, that's one thing we can add now. Okay. Placebos. A pharmaceutical company is testing a new headache pill, medicine pill, and which is to test it on an experimental study against a control group. Is it possible for the experiment to be blinded or double blinded? The subjects can be blinded by giving a placebo, a dummy pill, which looks and feels the same as the real pill, but has no active ingredients. Active ingredients are what make it work, right? Any prescription or any drug that you can buy in CVS or Walgreens or Target has an active ingredient. The active ingredient is what makes it work. It's got a whole bunch of other stuff in it, but the active ingredient is what makes it work. So there is no active ingredient for a placebo because they don't want it to work. They want it to be just like you're drinking water or, The evaluator should be blinded by not knowing which group received their drug versus the real drug. Should be administered by a third party, okay? Placebo effect is a real thing. Placebo effect is a real thing. If I'm taking a pill that makes me smarter and I'm in a group of 50 people, so there's 50 people in the treatment group and there's 50 people in the placebo group, right? We expect the people in the treatment group to get smarter over time if it really works, right? People in the placebo group, some of them will get smarter, even though they got the placebo. Well, they're like, why did some of these people get smarter? Because of something called the placebo effect, okay? So you will have some people who it happens to. Whatever drug you're giving them, even though I'm giving them a drug that is a placebo, it has no effect, has no active ingredients, it'll happen. Sometimes it'll happen. It's called the placebo effect. It's a real thing. Doesn't happen a lot, but it will happen if you have a big group of people, okay? We don't expect it to happen as much as the other group, but we're looking for that to see which one is better. Okay. Okay, so the last thing of the chapter. There's two. So the ones we did on Friday, let me pull those up. The ones, it's the same one. So the experiments we did on Friday, right? These experiments we created 2 in class. Those are what's called completely randomized experiments. That's what they call a completely randomized experiment. Here's one type that is not a completely randomized experiment. It's called a block design. Okay, it's a randomized experiment, but it's not completely randomized. It's called a block design randomized experiment. Okay, so what is a block design? A block design is when an experiment is conducted separately for different groups. So you create 2 or 3, 4, or 5, whatever you want, blocks of experimental units. We use blocks if we expect certain groups of units or subjects to systematically affect the response to the treatments. It's similar, same idea as stratifying. So if I think a group of people are going to react differently than others, I might decide, you know what, I'm going to break it off into 2 separate experiments. Okay, so for example, this outline here we did for the online class, right? Let's say most students who take the SAT are in what grade? What grade are most students who take the SAT? Juniors, and maybe a few seniors. A few seniors in the fall who haven't applied to school yet, right? So mainly juniors, but also some seniors. So how could I block design this? Well, what I would do is, before I even started any of this stuff, I would say, you know what? I don't want to mix the juniors with the seniors. So what I'm going to do is I'm going to separate them. I'm going to run one experiment all the way through with all juniors. And then down here, I'm going to run the same experiment with all seniors. I don't want to mix the juniors and seniors, right? Because the seniors might have a little more knowledge than the juniors do because they've taken the test before, they've had another year in high school. So I want to separate them. That would be blocked by grade level, right? Another way to block it, I don't want to mix genders, so male and female. So I'm going to break these 100 up into male groups and female groups. So females are going to go through the whole thing on their own. Males are going to go through on their own. Now, this is where it's different. I don't compare male versus female. I only compare males versus males, females versus females. Same thing with 10th or 11th graders. I'm only comparing 10th graders with 10th graders. I'm only comparing 11th graders with 11th graders. The way we did it before, I compare everybody with everybody. I compare everybody with everybody, right? I compare all of these guys with all of these guys. Well, that's what I would do in block design. The only difference is the only people in this group are 10th graders, or sorry, 11th graders. The only people in the other group are 12th graders, right? So I'm only comparing online class of 11th graders with in class of 11th graders. I'm not comparing them with 12th graders, and same thing with 12th graders. 12th grade online with 12th grade in class. Okay, that's what we call blocked. So we say it's blocked by gender, blocked by grade level. We do that when we think that we don't want to mix data. We want to keep them homogeneous. We want to keep the groups homogeneous and compare only within, right? Sometimes we need to do that, sometimes we don't. Okay, so that's what block design is. So there's a little more into what block design. Completely randomized designs are the simplest to treat statistical design for experiments. But just with sampling, just as with sampling, there are times when the simplest method doesn't yield the most precise results. A block is a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the results, the response to the treatment. In a randomized block design, the random assignment of experimental units to treatments is carried out separately within each block. Okay. Form blocks based on the most important unavoidable sources of variability, lurking variables among the experimental units. Okay. It's not the same as a completely randomized design that we did on Friday. Okay, we're going to do one that's a randomized block. That's the one we're going to focus on today. Okay, so let's skip ahead a little bit. Skip match pair for right now. Let's do this one right here. People will use less water. That's the conjecture. Okay. People will use less water in the showers if they can't control how hot the water gets. Okay, that's the conjecture. The setup. There are two types of showers. I have one shower that allows water to get as hot as they like, so they can control. They have the ability to control like you do in your shower when you take one. The other allows hot water. The other one only allows it to be 120 degrees Fahrenheit. Now, 120 degrees sounds hot, but it's really just your basic hot, warm shower. It's basically it. Okay. So it's not like scalding hot, and it's not like really cold. It's kind of like your basic, yeah. But some people like it hotter than others. Okay. So 120 degrees Fahrenheit, which is usually hot enough for most people. Some people like it hotter, but it's like your normal hot shower, hot or warm shower. Okay. The participants, 100 people who just exercised, so they need a shower. 50 are men, 50 are women. So we're going to create an experiment, all 4 steps, but we're going to also block it for gender. Now, they didn't tell us why, and it's not really important, but why would we block it for gender? Why do you think they want us to block it for gender? What are some reasons why? One gender might respond to hot water more than others. My wife, when she takes a shower, it's scalding. It's literally scalding. I don't know how she sits in there for as long as she does. I couldn't even sit in there for 10 seconds. It's just scalding hot. I mean, I like a warm shower, but I mean, hers is just like boiling. So some people, yeah, that it's preference, right? And then they talk about how much time or less water. My wife and I take more water, take more time in the shower. She's done within like that. She gets in and gets out really quick. I don't even know how I don't know how she washes anything in that fast. She just goes in and goes out. And she says, I take a long time. I don't think I take a long time. I take a normal amount of time, but she takes like really fast showers. So it's different, right? Just be in my household. It's very different, right? And then my sons are the same way as me. You know, they take showers about the same, take showers, shake baths the same length I do. So I don't know if it's a guy-girl thing. I don't know what it is, but there's a reason why they want to block it for gender. So in this case, they're only going to compare the females with the females, the female treatment groups and the female control groups, and the males are only going to compare with the males. We're not mixing genders in this one. That's what that means. Okay. So we got 50 and 50. So when we start out when we do our outline, we're going to start with, we're going to start with 50 males. And then down here, I'm going to do a separate experiment with 50 females. Because really, you're doing the same exact experiment twice. That's what blocking means. Okay. So as soon as I set one up, I can set the other one up just the same. I don't want to do them differently. I want to do them exactly the same. All right, so how many treatment groups are we going to have? We always have one control group, but how many treatment groups are we going to have? So in that treatment group, who's going to be the treatment group? So the group that only has 120? And who is the control group? Is that okay? I know you think it's fine, but I'm trying to think of everyone else. Does anyone have an issue with that? So treatment, so two groups. Treatment group. Control. So treatment being 120 degrees, that's it. Control being you can literally control the shower as it goes. That way, or should we flip them? That's a good question. Does it matter? Does it matter which one's which? Yes, it does, because we're going to have to explain it later. So what's the question? People will use less water in showers if they can't control how hot it gets. So which one's going to be the treatment? Does anyone else say anything else? You guys say the exact same thing? There you go. Okay. Well, no, I'm not picking on Aldrin. It's just I heard one voice, and I don't want to assume that's everyone's voice, right? So speak now, or forever hold your peace. All right, exactly. I'll hold my peace until I find out the answer. So if the question says we're trying to test to see if they can't control, that's what the treatment's going to be. Okay, so the treatment's going to be 120 degrees Fahrenheit.
Yeah.
Okay. Controllable. Not water, controllable degrees. Temperature, there we go. Okay. Numbers. 20, looks like we're gonna have 25 and 25. So this is gonna be 25 males. And this is gonna be 25 males. There you go, yep. I was just about to say that right here. I'm gonna have to do a random assignment here and here, right? They're not gonna be able to pick which shower they get. They're gonna have to walk into a shower that I tell them to go to. Can I blind this? Can I use blinding for this one? Or double blinding? They're gonna find out, yeah. There's no way to blind it or double blind it, because exactly, you either walk into a shower with a regular nozzle on it, or you walk into a shower with no nozzle on it and it's just coming out, right? One temperature, right? So there's no way to blind this or double blind this. Sometimes that happens. Okay. All right. So last thing we got to do is compare. What are we comparing?
The amount of water they use. How can you compare that? You measure the water, right? Yeah, it's better to just do time.
Time. I think time would be easier too. Yeah, it's kind of hard to measure unless you have some sort of Unless you have like a bucket underneath, like just holding the, yeah, I think that'd be a little,
A really big bucket.
okay. So compare shower times. Compare shower times to see, we'll explain this in our explanation, but to see who's where, okay? So now what we're gonna do is we're gonna go down here and we're gonna do the exact same thing for females. So we're gonna say treatment.
No.
You guys are doing
makes sense.
It's a different something torture for longer than 5 minutes. See, so much water you save. So much money.
Cold
This is
shower.
drain, literally.
Cold
Alright,
shower.
You seem to be forgetting something.
Just get more water, bro.
Cold shower.
We live near an ocean, don't we? Can we just get more water?
We're in a drought. And that
Just
drought-
make it rain,
And that
then.
drought is fully caused because of my hour long shower.
Marianne, just do a rain dance or something.
Bro, I sit in there and have a concert. and it's just-
What is summer in Seattle by winter?
I forgot I told you. I have shower rocks.
Just do a rain dance.
Don't get- that's what we're doing.
Look, if we all band together and do a rain dance, right? Eventually it's gonna rain. Look,
Okay.
It's already raining, guys.
So we have,
the quality, like, how's the air so bad?
okay, Yep. all right. Okay, so that is that's diagram, that's the first part. Second part is we have to explain how we did randomization, how we took care of replication, and how we did control. So, okay, so the first thing is randomization. Okay, so anywhere there was an RA on our diagram, we have to explain how and why we did it. Now, again, if they want us to do it a certain way, we have to do it that way. But if they didn't specify which way they wanted us to do, just explain which way you did it. So for example, they didn't explain, so I would say, first thing I'm gonna do is, what's always the first thing you gotta do when you're doing any kind of randomization? Assign numbers, yeah. So some sort of assigning numbers to each, assign numbers to each subject. I'm going to try to write it so that I'm going to try to write it not vague, but I'm going to try to write it not specific so I can use it for both males and females. So I'm going to assign a number to each subject. I'll say 0, 1, 2, 5, 0, and 5, 1. Yeah, I could do that too. Or what I could just do is this too. 1 to 50. Give every male a number from 1 to 50. Give every female a number from 1 to 50. I could do that. You could go 0, 0 to 49, 50 to 99, 0, 0 for males to 49. 50 to 99 for females. You can do that too. There's nothing wrong with that. Okay. After that, okay. So I would say, first 25 chosen, randomly chosen. Oh, whoops, nope. I got to say how I'm going to do it. How am I going to randomly choose people? Use a calculator. A calculator to Use a calculator as a random number generator. First 25 go to the treatment group. This way I can do males and females at the same time. Next 25 go to the control group. Okay. That's how I came up with my groups. Okay. Replication. So when we're explaining replication, what's the important thing? Numbers, right? Numbers. How many times do we go through it? How many times do we go through it? So we want to definitely explain numbers. So here we're going to say not 100 because I'm not doing it 100 times. I'm doing it 50 times for males and 50 times for females. Or not 50, I'm doing it 25, yeah. 25 there's 50 showers. Yeah, I guess we could say 50 because there's 50 showers going on in the males and the females, and we're just comparing 25 and 25. So we could just say, so the easiest way is just to say numbers, just to say 50 males will complete experiment. Watch this. 50 females will complete experiment. You guys know what the little quotations mean? It's repeating. It's repeating quotations. Okay. Easy enough. Control. So which one's the control group? Control, yeah, will be the groups that can control the temperatures of their showers. We can't blind it or double blind it. We explained that. Because eventually when they get in there, they're going to know if they can control it or not. So we explained who the control group was. The next thing we have to do is explain, how am I going to know if it works or not? What am I going to do? We will compare average shower times for treatment groups versus control groups or groups. We also want to say it's blocked for gender. So we'll say blocked for gender. Blocked for gender. So we will not compare outside of gender. So I'm not going to compare male time with female time. I'm not going to compare female time with a male time. I only compare males with males and females with females. So I'm going to get two results from this. Maybe females respond one way and nails respond a different way. We don't know. Mhm. Sure. Okay. So let's say we were able to blind it. Let's say we were able to blind it some way. Obviously we can't for this one, but let's say the next problem we can blind it. Where do I explain it? You have to explain if you're going to blind it. I would explain it under the control. It would be another bullet. Experiment was blinded by or double blinded to ensure that no one knew or whatever. You would explain it there. Okay. Okay, so we got about 11 minutes. Let's see if I can get another one here. So go to the pizza one. Freschetta frozen pizza. It's the one that has, there's a couple of them that have that, but the one that looks like this, where it says block based on whether they eat frozen pizza. Okay, so in the last 10 minutes, I want you to set up a experiment for this one. So the conjecture is this pizza company claims that people who eat their pizza will think it's actually from a pizzeria, right? Rather than store-bought. Okay. So you're going to block by based on whether people have eaten frozen pizza before. Okay, so create your outline and then go from there. So how many blocks am I gonna have here? Like the last one I had 2 blocks, males and females. How many blocks am I gonna have for this one? 2. What are they gonna be? People who have eaten frozen pizza, people who have not eaten frozen pizza. Okay. So it says 50 who've never eaten frozen pizza. So 50 people who never eaten frozen pizza. Okay, that group is 50. Who's my treatment going to be? The frozen pizza, yeah. The frozen pizza is going to be my treatment. So my treatment is frozen pizza. That means my control is, it says store-bought, but store-bought to me sounds like frozen pizza. So it should be like pizzeria pizza. Pizza shop pizza. Yeah.
How is it a treatment control if they have both pieces?
Oh, okay. So the way we're going to do this, what you're talking about is what we're going to talk about tomorrow with more of a match pair. And we'll do this again. We're going to do the same experiment again with what's called a match pair. And that's exactly what you just talked about, Josh. But today we're just going to do, we're going to do this. So let's see. So we have 50 and 50 or 25 people and 25 people, right? Okay, so what would we measure? We'd compare what? How would we compare? Yeah, because we're going to create some sort of scale, right? 0 being the worst pizza you ever had, 10 being the best pizza you ever had, right? So we're going to compare their taste testing results, okay? Their taste testing opinions. Okay. Random experiment. Can we blind this? Is there a way to blind this? We could, right? How could we blind them? Literally blind them. Yeah, put a blindfold on, have them say, grab the pizza in front of you, take a bite. Right? We could do that. We would explain that later on. We could do that. Okay. So we're going to finish this tomorrow and then we'll go on to match pair tomorrow. Okay. So we're going to finish this tomorrow. So the second one is just going to be a repeat of that one, just different numbers.